exponential equations. Tomorrow we'll work on logarithmic equations, how to solve them. So in number 1 we're solving for what? X. Okay? Oh, let me focus it. And if y'all remember, they have to have the same what? Base. Okay. Come on. So when you're finding the same base, you always look at the smallest number, which is what in this one? 3. Okay. Can we raise any number to a power to get the number 3?
No.
Nope. So we can't change this one. It has to stay 3. Again, there's no number that we can raise to a power to get 3. But now that this has to stay the same, this base has to become what? 3. And we'd write it as 3 what?
3
Squared. Because 3 squared is what? 9. So we'll write 3 squared instead of 9, but we also have to bring down the what? The 4. So now we can do what? Yeah, cross out the bases, and we'll have x equals what? That's it.
Okay.
Now, how to check this? Yeah, you plug in 8 right here, and somebody in their calculator type in 3 to the 8th power. Tell me what you get. Darian, say it.
6,561.
Alright, now somebody type in 9 to the 4th, the other side. See how they're both the same? That's how you check it. Any questions on that? We're going to do a few more together, and then the rest of these we're going to come back after we finish the back side. Number 3? Okay. What's the smallest number?
2.
And can you raise any number to a power to get 2?
No.
Nope. So it has to stay the same. That means this base has to change to what?
2.
And what power do you raise 2 to get 16? Yes. So it'd be 4. Got to bring down that exponent of 1. Now you do what? And we have 3x minus 8 equals what? And then we would do what to solve? And so x is?
4.
Very good. I'm hoping y'all do really well on this test.
This is the last number.
This last one before Thanksgiving. And then after Thanksgiving, you only have one more test.
Would that be the semester test?
No, you'll have one more before the semester test. Yes. Yes. Study guides I'm handing out Monday, this Monday.
Wait, so how many weeks do we have looking at?
2 plus exam week, so 3 actually. 2 full weeks. Yeah, full weeks. No. Okay, next. All right, let's do number 6. Okay. What's the smallest number?
4.
All right. What can we raise something to a power 2 to get 4? 2 what?
2.
Squared. So let's rewrite this as 2 to the 2nd. What else do we have to bring down? All right. So we know the base over here has to be what?
2.
To the what power? In parentheses, x plus 2. Everybody good so far? Cross out the 2's. Let's go ahead and distribute while we can.
3x
Equals. What do y'all want to combine first? X's or constants? So subtract 2x from both sides and get x plus 6 equals negative 6.
And that cancels out. So what?
Yeah, it doesn't cancel out because we got to move this over by doing what?
Oh, get subtracting.
So x equals? Perfect.
Okay.
Alright, the rest of these we're going to come back to because I feel like y'all are comfortable with these, okay? Flip it over. Alright, these are still exponential functions, but we're going to have to solve these with logs because you'll find out you can't find a common base. Like, look at this 4 and 15. Is there a common base here?
No.
No. So we're going to have to use logs to solve it, okay? So here's the steps. First, we're going to isolate, which means just get by itself, the exponential expression. So right here, the exponential expression is this 4 to the x. Is it isolated by itself?
No. Wait, yes.
What's beside 4x?
Nothing.
Nothing. So it's isolated. The next, we're going to take the natural log on both sides for bases other than 10. Okay? This base is what? 4. It's not 10. So we're going to take the natural log of both sides. And natural log is ln. So this would look like ln of 4x equals ln of 15. Taking the natural log of both sides. Alright, and now we're going to use power property to rewrite this one. Okay, where can we put this x out? In front. So tell me how to write that. Oops, my LNs are looking ugly today. Do you know why I did that? Well, we can't solve for x if it's an exponent, right? But now how can we solve for x? Good. Divide everything by what? Perfect. So x equals ln of 15 divided by ln of 4. And you know you'll have to use your calculator to find that. I want you to round to the nearest hundredth. So try it on your calculator and let's see if we can all get the same thing. What'd you get? Yeah. Actually, I'm sorry, I don't have any more. What you can do if Alyssa will let you is like after she uses it, she can let you try it. What'd y'all get? Very good. Now, if you didn't get this in your calculator, it might have to do with parentheses. Did anybody not get this? Okay, let me come help you. If y'all want to, you can try another one while I'm helping. Yes. Anybody else having trouble?
Okay.
So you hit 15 first, then hit 11 divided by, and then now put parentheses, good, and then type that in 4. Then close it. Then hit enter. There we go. Anybody else? Alright. If you look at this, the directions, make sure that you read number 2 carefully because it says take the natural log on both sides for bases other than 10. What's number 2 got?
10.
A base of 10. So it's a little different. We have to take the common log, that just looks like log, on both sides for base 10. And here's some properties that you will have on your test on the board. You won't have to memorize these. But here's one. Don't forget ln of bx. You can write it using power property as x ln b. We just kind of did that for number 1. Also, don't forget ln of e raised to the x. Everything would cancel out except that exponent. So these cancel out to be x. And don't forget that log 10 to the x would just be x. And I'll explain this after you write it down. If there's not a base here by this log, it's what? 10. Okay? So these that I'm writing down are the same. So what do you raise 10 to get 10? 1. So that's why it cancels out to just x. Everybody see that? These are properties that'll be on the board, but we're going to use these if we can. Yes?
What's the difference between ln and log?
One is a common logarithm, one's natural log. I don't really know the definitions. I'll have to look it up. Alright, so on this one, it's got a base of 10, so we're going to use the common logarithm. So here's how it looks. Log 10 to the x, log 120,000. And we only use common log when there's a base of what? 10. Alright, so everybody see what's going to happen on this side? It's going to cancel out to what? Good. So this is the property we're using here. It cancels out to just x. So now all you have to find is log of 120,000. And whenever you get it, you can say it out loud. Good. Make sure your calculator tells you this. If not, I'll come help you. Everybody's calculator good? Okay. We are going to do a few more together. Let's do, 3 and 5.
What about 8?
Those are different. We haven't got to those yet. Alright, let's do 3 together. Does this have a base of 10? So we're going to start by multiplying each side by what? ln. So ln 5 to the x equals ln 134. Now what? Yep, power property. This will change to what? Next. Very good. So x is approximately, good. Questions? Yes. In your calculator? Yes. Go ahead and try some more while you're holding here. Alright, number 5 is different because the base is what? E. Okay? But it's not a base 10, so we're still going to multiply both sides by what? Yes. So ln e to the x equals ln 0.83. And now using this property, the ln and the e will cancel out and you'll just have that exponent left, which is what? Just x. So x is ln of 0.83, and all you have to do is calculate that. So it'll be what?
Yeah, it is negative.
Yeah. Sorry, I was looking at the wrong one. Is this what y'all got?
Yes.
Yes. Alright, I want you to try 4 and 6 on your own. If you don't have a calculator, if you'll just share with people around you. So once she gets done, Jalen, with hers, you can use it. Just 4 and 6. 4 and 6.
Does the 9 cancel as well if you divide it? Or would it be 9 to x?
First, you have to isolate the exponential, so divide everything by 9 first. Then do it. It's in your subject. That don't mean you don't get the time. Come on. This one's just like this one. Just follow the same steps. Yeah. guess everybody's done. Who wants to tell me how to start this one off? Go ahead.
Log
All right, Darian, what next?
you gotta cancel out for log 10.
And you'll have.
X equals log of 8,000.
All right, final answer, everybody?
X equals 3.9.
Perfect. Any questions on that one? You want to help me out with the next one? You have a question?
Oh,
Okay.
I'm not done with 6, so.
All right.
Will it always be a decimal?
Most likely.
Okay.
Next one, you would do what first?
Divide 9 on both sides.
Yes. Okay. So a lot of y'all are trying to do the ln step first, but we have to isolate the exponential equation first, which is this e to the x. So just like Solomon said, we got to get rid of this 9 by dividing the whole thing first. So that'll be e to the x equals what?
11.89.
11.89. Okay. I left it as a fraction, but that's fine. Now we multiply both sides by what? ln. Good. So we have what on this side? Equals this. And what'd y'all get? Good. Does everybody feel comfortable with those? Most of those are just one-step equations. This one was actually 2 just because you had to divide the 9. The only difference between the ones that are down here is that you have to isolate the exponential part first. So like on this one, we need to move the what first? The what? 3. Good. So 40 e to the 0.6x equals 240. Then we would do what? Everything by what? 40. So we have e to the 0.6x equals what? Now what? Good. Alright, what are we going to have on this side? Good. Equals?
Can you go ahead and do that like ln6?
Sure.
I got 1.7.
It might mess up your rounding. You get what I'm saying? Like if you round that part off, ln6, it might mess up your answer. So let's just leave it as ln6 after all. You get what I'm saying? Like if you round that off, it might affect your answer. Alright, what would we do from here? Yep. So in your calculator, you would type in ln of 6 divided by 0.6. I'll give you time to do that. Did anybody find it yet?
2.99.
Good.
I got the same answer.
Okay, then that's fine. Alright, I want you to try 8 on your own. I can. Anybody want more time on number 8? Okay. Alright, Katie, help me out with the first step.
I added 5.
Alright, so that gave us 7e to the 2x equals what? Alright, Miles, what'd you do from here? Yes. So that gave me e to the 2x equals what? Okay. Kyle, what'd you do from this point?
I did the ln, and then I counted that out. And then we did the
Very good. So it gives us 2x equals what? ln of 9, right? And then I would divide everything by what? 2. So this is what you would type in your calculator, and what'd y'all get for your final answer? Good, that's what I got. On your test, I'll tell you what to round to, so there won't be any confusion. Alright, 9, 10, and 11 are a little more lengthy, okay, but still possible. I'm going to start with number 10 because I'm going to run out of room on number 9. Alright, what do you think we should do first?
Same base.
Same base, so we can find a base between 3 and 7? Nope. So what next? Don't think too hard. Same process we've been doing. ln on both sides. So ln 3 to the 2x minus 1, ln 7x plus 1. Can't we rewrite these? Yep, we can rewrite these using power property, right? So I can take this and put it where? Out front. So 2x, I'm going to put it in parentheses, minus 1, ln of what? Just 3 equals? Good. ln of 7. So just use the power property to move them out front. Alright, our goal is to get x by itself, correct? This is what we're going to do now. We are going to write these as separate natural logs. Separate natural logs. We're going to split these up. So this is how I want you to write it. 2x of ln 3. 2x of ln 3 minus 1 of ln 3. But I can just write minus what? ln 3. And now let's split these up. Tell me how I'd write that. Good. Plus? Good. My LNs are just looking terrible. I know. Let me rewrite that. It just bothers me. ln of 3 minus ln 3 equals x ln 7 plus ln 7. Alright. Which two look like they could combine, like terms? So these and what? And these, because they have x's out front and these don't have anything out front, right? So let's put them on the side with their friends. Let's put them with their friends, okay? So let's move this ln 3 over to this side with its buddy. And let's move this one over with its buddy. X ln 7. Now we can't combine these. We can't just say like x ln 7 and 10 ln or ln 10. But this is what we can do. We can group them. So here's what I mean. We can take out, let me rewrite it first. 2x ln 3 minus x ln 7 equals ln 7 plus ln 3. What do these have in common? These right here. X. So let's take it out. And I'm going to have to, I'll write it right here. So tell me what would be in parentheses if I took an x out of this. 2 ln 3 minus ln7 ln7 equals, and we can't combine these, so I'm just going to leave it ln7 plus ln3. Now, why did I take an x out? Yeah, because I could, but why? What purpose does that serve in us solving this? Because it's by itself. So now the only thing I have to do to solve for x is what? Divide everything by what? Yes. So this would be x equals, and I'm going to come over here, ln7 plus ln3, all divided by what? Yep.
Does the order matter on the right-hand side?
On this part?
Yes.
Yes. Because, like, if I asked you 2 minus 4 and 4 minus 2, they're two different things, right? So,
On the added side.
this one? No. When you add them, it doesn't matter, but subtraction does. Alright, there's two ways you can do this. You can either find out what the top is, write it on top, find out what the bottom is, write it on bottom, then divide, or you can type this all in your calculator. I want you to try to do that now. What now?
You need to put it in parentheses.
Yes, you'd have to put this in parentheses when you divide. Did anybody find it? Say it louder a little bit. That's what I got. I actually got 114. But did everybody get this?
No.
Alright, let's see why. Do ln7 plus ln3 first. No, you don't have to. ln7. And then plus.
Miss Horton?
Yes.
May I have Victor Tart to main office?
Yes.
Thank you.
Close one to the center. That's the top. Now do the bottom. Now you will not have one like this, like on your test. You might have a bonus. Hint, hint, like this on your test, okay? But I'm not going to put one of these on your test because it would take you a little while to figure that one out.
10 minutes.
Miss Horton, do that one problem.
Miss Horton.
Yes.
I'm sure I put this in.
Yes, I will. But while y'all are sitting here, you are to finish what's on the front. These 1, 2, 3, 4, 5 problems, I have to check them. If you get them correct, you can pack up. Or what I would do is work on my study guide while it's fresh on your mind, because these are on your study guide.
Let's do the top first then. So just do 1, 3, 4, 5.
I mean, ln7 plus ln3. You don't have to. Let's write that down. Okay. Now the bottom, let me just make sure this is right. Yes. So let's type in 2 ln3. I'm going to write them down. Now divide. And people who didn't finish their checkpoint from yesterday, I'm about to pass out your papers, and I'm going to write the problems up here so you can work on them. This is the checkpoint problem from right here.
No, that's what we have to do before you leave. Like she said. No, she came up with thing from yesterday. She did like
this.
I thought you told me.
Finish these first and work on the shipment. Good, you got it.
Yeah, ready.
I got to pass you back. Darren, didn't I just say work on this and Miles too? I want to ask you again.
I need my checkbook.
You're working on the front page until you get your checkpoint.
What?
I think this is yours. Are you done with this? Any checkpoint? You've already calculated? From this check? You want me to check? And you finish. That negative 11? Okay. Great. Great job.
Thank you. Do like those for me?
Perfect.
That is evil.
We don't have to do that one right now. Yeah, that's the one that she said we didn't do that one. Because we were, that's it.
Okay, so now you need to calculate. So see how this had 6 to the 5th? And they brought the 5 where? No, you can leave it right there. No, don't change the equal sign. They just changed this by putting the 5 out front. See how they did that? So that's all you put meaning into. So move the exponent out front. Out front of log. Don't erase this, just write it below it. Rewrite it below it.
We go back and forth, they get the same
Almost right. This is almost right. This 12 is being raised to 5 times 6. So what's that exponent going to be? So what's that going to change here? is going to be what? How did you get a 12 right here? It should be right here. All you did on this one was just from 10 out right? Right for 12. So what should be right here?
Two.
Like this two. Yeah. You don't change that, but just bring the answer over. And this one is just like this one. Except it's instead of plus it's minus. So instead of multiplying, it'll what? Yeah. But first, you see how yours just looks like this? Go backwards. So instead of like this is log 2x to the what?
This is a little bitty 2, 15,
Rewrite it and do the quotient.
and x to the 18 over y.
And one's an X and one's Y. You're just condensing into a single one.
That's log. Justin, are you asking him for help on the checkbook?
No.
Okay. Turn around. Alright, this part is 7. Alright. If you're ready for me to take your checkbook, just put it again, and I'll take it.
That grade is not correct.
We're just singing the whole time, bro.
This song, what did they move out front? The exponent. What's the exponent? What's the out front? Yes.
I don't know if that was done or not.
Almost. This 12 is being raised not just to the 2 powers.